Okay, just a review of what happened. The original problem was 7 over 3k plus 5k plus 1 over 2k squared. We wanted to find the LCD, which is the LCM of these two numbers. The LCD of 3k and 2k squared, 6k squared. Then I have to ask myself the question, what do I multiply 3k by to get 6k squared? Magic number, 2k. So I multiply the numerator and denominator by 2k, and then I get this new numerator. Let me ask this question. 7 over 3k and 14k over 6k squared, are they the same value?
Yes.
They're the exact same value. Someone tell me why that has to be the case. They have to be the same value because of?
Some property, maybe?
It is some property, maybe. Identity. You multiplied by 1, you keep the same identity. And then we multiply this one by 1, same identity. All right, this is a review of 12-5. You have like denominators, so add the numerators together by adding like terms. So like terms gives us...
How come K stands for thousand?
Like kilo, I guess. That's my explanation, like kilo, kilogram. Okay. What's 6k? What do I write for my denominator here, guys? Oh.
Kilos.
Oh, yeah, wow. 29, yeah, because 14k plus 50k is 29k. Thank you. And then what do I do with the denominator? Keep it. So it becomes 6k squared.
My life is so confusing.
Okay, now listen. On this rational expression at the end, even if I tried to factor the numerator, which I can't, there's nothing to cancel, so this right here is my final answer for that problem right there. Okay, that's what you get. That's your simplified form of adding those two together. All right, let's start off fresh with a new one, but this time we're going to subtract 3p over 4q, and again, make your q's and your 9s look different enough, minus 7p over Q. So this time I'm subtracting, but it's the same process. The first thing I have to ask, what is that LCD? What's the LCD of 4Q and Q?
4Q.
It's just 4Q. So I want to change, if I have to, both denominators to be 4Q. So can I do 4Q divided by 4Q evenly? Can I divide that evenly? Can I do 4q divided by q evenly? Yes. So that's my LCM of the denominators. Did I have to multiply this fraction by anything? No, you can say by 1, which is what you're going to do every time, but that still leaves you at 3p. What do I multiply the second fraction by? 4 over 4. So I get 28p over 4q. All right, I have a common denominator. Now I can subtract. What's 3p minus 28p? Negative 25p over 4q. Okay, we're also going to add this in. I'm going to talk more about this as we go. When you get your common denominator, you can find your excluded values, because you got to find excluded values again. So what's the excluded value in this problem? Q cannot equal?
0.
Q cannot equal 0. Yep, that's a nice one to find. And yes, you do have to identify excluded values again. Okay? You guys get how to do those problems? Those are nice, aren't they? Oh, then these are going to be really hard. Negative 4 over, here's where we start getting a little bit more going on. X squared minus 4 plus 1 over x minus 2. Okay, so here's our problem. We're trying to add these two together, but we don't have common denominators. I want to find that LCD, but in order to find the LCD properly and easily is if I factor. I'm going to factor. So especially the denominators, but I could do the numerators as well. In this case, it's really easy. So I'm just rewriting this time. What does x squared minus 4 factor into? X plus 2, x minus 2. So that's the binomial. Those are the binomials, excuse me. And then x minus 2. Okay, can anyone tell me what the LCD is? What's the smallest denominator that both of these can fit into?
X squared minus 4.
Okay, x squared minus 4. That's actually correct. So what I'm going to say is in the factored form, x plus 2, x minus 2 for both of them. Because what is x plus 2 times x minus 2? X squared minus 4. So that is the common denominator. I don't always know that x squared minus 4 is the common denominator until I factor. And especially with trinomials, it's going to be a little bit less clear. So this one, that's my common denominator. X plus 2 times x minus 2. What do I have to multiply the first fraction by to get that denominator? By 1, or you could say you don't have to multiply it, but here it stays the same. What should I multiply this fraction by to get that denominator? X plus 2 over x plus 2. What is x plus 2 times x plus 2? Sorry, what is x plus 2 over x plus 2? 1. So we're still using that property. And then what is 1 times x plus 2? X plus 2. Okay, before I can, right? Some of you are saying, well, can you just cancel these out? Yes, you could cancel them out, but would you have a common denominator anymore? So you want to keep it like this because now I can add, that's my goal. So what do I actually add? The numerators. So here I have, what's negative 4 plus x plus 2?
X minus 2.
Yeah, x minus 2. You could also say negative 2 plus x.
Then they wouldn't cancel it out then.
Just a moment, just a moment.
Yes.
That's a weird X. We'll pretend. That looks more like a chromosome than it does like an X. Okay, anyway. Gross. It just contains everything about you physically. Which is really cool, right? These chromosomes contain everything about you. Everything. Everything about your physical appearance and your person. All right, what are the excluded values? X cannot equal 2, and x cannot equal negative 2. All right, but is that a simplified answer? What am I left with? 1 over x plus 2. 1 over x plus 2. That's my final answer because I canceled those out. Yes, so much simpler.
Why?
But do they always look simpler after you work them out? Good answer. Oh, some of you are going to be shocked. Okay, I want you guys to do this one by yourselves. See how you're doing with this so far. G minus 1 over 2g. Oh, that is not a g. And you're adding g plus 3 over 6g. G plus 3 over 6g. Oh, that's weird. It's like I'm saying something, but I'm not writing that down. Okay, that's what I want you to work out. G minus 1 over 2g plus 3 plus g plus 3 over 6g. It's my lunch. It's getting to me. It's the Super Bowl. I'm still hurting. Don't judge me.
I'm still being happy.
Would you say that the best team won the championship, Will?
Yes.
Interesting. Would you say that about all championships?
No.
Oh, interesting.
Different circumstances.
Would you say that about the same sport?
Yeah.
Good answer.
No.
You already said yes. You've been quoted.
No.
That's why I like Will. Oh, I already did.
I'm not going.
Sorry, you fell into it.
No, I said that.
Oh, Tom.
He's talking about football and he's saying that.
Mr. X.
Sir?
Why are you using that?
How? So, who did this morning on our list in the regular season?
Doesn't matter.
Every team lists their worst team. So it comes from us, Pittsburgh, 1 year, and then we went and won the Natty. It's just like the best team didn't win. But then they ended up winning later on in the season.
Gotcha.
But y'all didn't end up winning.
Yeah. We only have 5 right now. That's sad. I want that 6th. I want one Bill Belichick has on his fingers. Okay.
Some teams won at 4. We couldn't.
All right. Did you guys get an answer on this one? Okay. Let's go with this. I want the excluded value from Sophie. Excluded value. G cannot equal?
I don't know if this is right, but 1/6.
Not 1/6. It can be 1/6. So, exclude.
Natty.
Look at only the denominators.
0.
Yep, G cannot equal 0. G cannot equal 0. But I want a simplified version of this sum. Nelson.
4G plus 2 over 6G.
4, say that one more time.
4G plus 2 over 6G.
No, I got 1/3. I got.
That's okay. You're close because you got the denominator's good, but the numerator's a little off.
Yeah, I got 2G over 6. I got 2G over 3G.
Yes, me and Will are correct.
I got 2G over 6G and then I got 1.
You guys so close.
1/3.
2 over 3. 2 over 3.
So 2G over 3G?
2 over 3. Because the G's can cancel.
Oh, yeah. I still said we were right.
You have an equivalent value. You do.
Yeah, it's the same thing. It's just not.
How did you do that?
Don't forget, this is a binomial. Did you do 3G minus 1? And that stays the same. All right, Ellie, tell me what I do next.
You add
Ellie.
numerators.
What do I get?
You get 4G over 6G.
Yeah, I get 4G, and then negative 3 plus 3 is a 0 over 6G, which how many of you said, well, those can cancel out? But then those also cancel out, and you're left with 2/3. I wish. That was the middle of the road problem. Now here are the real problems. All right, let's do this one together. Yep. 1 over y squared minus 3y minus 1 over 3y minus 9. 3y minus 9.
This makes me scared.
Not yet. Okay, I want to subtract, combine, add, however you want to say it, but I need a common denominator. It's not super clear, so I'm going to factor. So the numerator, or excuse me, the first fraction, you could take out a y, you get y minus 3 times y. And then with the other fraction, excuse me, I can factor out another. That's helpful in finding your LCD.
LCD doesn't sound.
Yeah, same here. I don't know what's going on. No, something's going on. Okay, Josiah. I'm gonna work with you on this one. Would you agree that the LCD includes y minus 3? Like, is that common to both of them? Yeah, y minus 3 is common. That's part of it. But looking at just the numbers outside, what would be the LCD of just 3 and y? Does anyone, or you can help out, Josiah. What's the LCD of 3 and y?
3y. 3y.
3, it's 3y. 3y. So here's what my LCD is of everything. It's 3y times y minus 3. Now, can I divide this by the first denominator? Yes, I can, because what would happen? Those would cancel out, the y's would cancel out, and what am I left with? 3. 3 is what I'm left with. So what do I multiply this fraction by? 3 over 3. That's what I wanted. So what do I get with the first numerator? 3. That's all I did.
Find that out by saying 3 and a y on the dots.
Well, yeah. But you got to, but sometimes it's not that clear. But same questions we'll ask.
How did you get the 3y and then y minus 3?
Yeah, to find the LCD, this is where the tough part. You're going to have binomials in the LCD. So here's a binomial in there. It's its own separate thing, unit. And then what's the LCD of y and 3? We said 3y. So these are all separate things right here. 3 separate things. Okay, what do I have to do to the second fraction? What do I multiply by to get that common denominator? Y over y. Y over y. So I get y, because 1 times y is y. 3y times y minus 3. It's common denominator, okay? So do the denominators match exactly now? Are they like? So now I can subtract and I get 3 minus y over 3y times y minus 3. Wow, I feel like I've said that many times now. Y minus 3. Y minus 3. Okay, get me those excluded values, which you could do very quickly, I hope. And I said plural, so there's 2. And the reason that there's 2 is because technically, again, remember guys, this is a separate variable from, this is a separate quantity from that right there. So there's 2 excluded values. What's one of them?
0.
0. What's the other one?
3.
3. Positive 3. Excluded values. Not always, but if you just have a variable as a factor, yes, it's going to be 0. Okay, can this be further simplified?
Yes.
Yes, it can. So you just do this?
Sure.
No. Because they got to be exactly the same.
-1, then -3.
Force it.
Force.
Aren't these guys right here very close to each other? Switch the signs. So listen, I'm going to take out a negative, negative, positive. So, okay, now do we have some common factor? So I get, you can put -1 over 3y, or the negative sign right there, but -1 over 3y. Don't forget to force things if you have to. If it doesn't work, force it to work. The only time I'm gonna force it is if they have the same thing with opposite signs. So if they're the exact same, they're like a y and a 3, but they're totally different signs. Oh, force it, because you could switch signs by dividing by a -1. I wish I can give you your homework, but I need to know if you could do this one problem.
We can do it. That's all you need to know.
All right, there are many people. What, 3 people missing?
12.
So let's say
10.
16 of you. We'll go 16 of you need to get this next one right. You have to give me the excluded values and the simplified version, okay? 16 of you. Not much room for
How
error.
many do we have? Like 22?
Sorry?
How many do we have?
3 missing, so 21, I think.
Avery's not here, we'll remember.
All right, here we go. X over x minus 3
She's a rude farmer.
minus 3 over x squared minus x minus 6. All right, don't work together. This is on your own. I want this problem solved for excluded values. Simplified answer when you subtract these two together. right, I'll give you one help. How do you factor x squared minus x minus 6? X minus 3, x plus 2. Now 17 of you need to get it right. I'm just kidding, 16 is fine.
Do you have the Chromebooks in here? No.
No.
Yes, sir. When you're multiplying by x plus 2, so we do x times x plus 2.
Yeah, you have to do distribute that multiplication. Don't forget excluded values. That counts. I want it all, and I want it now. Just kidding. 30 seconds. Yeah, I'll explain that in just a bit. Okay, let's look at this one right here. I'm going to work it out, and then you can check to see how you're doing with that. I hope you do well. The LCD is x minus 3 times x plus 2. I'm going to multiply this first fraction by x plus 2 over x plus 2. X squared plus 2x. The second fraction doesn't need to be multiplied by anything. So I end up with x squared plus 2x minus 3 over x minus 3, x plus 2. All right, I can get excluded values now. So here's your first part of your answer.
Bro.
Yes? That's my excluded values. I'm going to look at this guy. He looks strange. And I get positive 3 minus 1. Oh, I want to force it. I want to force it.
You can't force it. You can't
So
force it.
I want to force it, but I can't because they're not opposites of each other. This part is opposite, but not that. So leave it alone.
Yay. Dude, I actually got it. Why is that?
I was nervous. I was nervous that 16 or more did not get it. All right. Raise your hand if you got it.
When I did the X plus 2. Yo, no. When I did the X plus 2.
10 of you got it. Wow. Thank you for being so generous on that.
For those who don't get it, don't get it.
For the people that got it, you should give them no homework and then
That's a
everyone else
thought.
homework.
I'll think of that. Sorry?
For the people that got it, they should get homework. Or they
Should not or should?
They should get it now. Half the people have to do one more problem. Yeah, that way it's fair.
I'll show you
You should start
fair.
doing that for the people who get it right. Here's the homework passed around.
Okay, if some of you are wondering what this is all about, let me help you out with this chapter real quick. So I make a little graph. It's not objective, so it's not like I can put numbers. I can put numbers here, but not really up here. Lesson 1 of this chapter, I would say it was a little difficult because you had to do excluded values and just wrapping your mind around that. Then you got into multiplying or simplifying more. Then multiplying, dividing wasn't too bad. Then you got to really combining fractions with like denominators. Then we kind of went to this with the homework. You're going to see, you're going to agree with me, it's a little tougher. Next lessons are going to go like this.
So like no,
Great, why
right?
does
That's gonna be hard.
Why doesn't it get
It's
all
a
the way?
unicorn.
Wait,
What's
It's a bird.
Wow.
Oh,
I didn't mean it for it to be a bird. I was just saying, that's what we're right here.
It can't get much harder than this.
Oh, it will. But after that lesson, you can say it can't get much harder than that. It won't.
How about we just go? I think the best part of the charts are the bottoms. Let's go back there.
These dots may not be high enough when I think about it.
It's all relative. So
It is relative. It could go lower.
yeah, maybe it's just like
Wait a second, Mr. Ed. Mr. Ed.
It doesn't go like
The higher it goes, the harder it gets. So,
But then it stops.
no, but will.
I thought it was getting easier.
No, it's going to be like, "Poop, what is this? Uh-oh. Now,
When did it get that easy?
this easy
Emojis.
when you added two fractions with common denominators.
I can't do it.
All right, guys, when you are quiet, I'll start working them out with you.
my desk.
If you guys don't want to be quiet, I'll just sit here doing nothing, which is not my preferred method of operating. Okay.
I like nothing. For example, no.
All right, so 8 through 13, all. You're adding or subtracting these. Number 10 is done for you. So you should look at it, because we probably won't get to that one. Well, we might not get to that one. It's possible. Oh, yeah, we got time. Okay. Write this down. Anyone still need it?
Yes.
Oh, we need to write that down.
Yeah, I would write your homework down so you know what it is. Or, no, that's just for your benefit. To scare you even before you've gotten to those lessons.
What's the point of scaring us?
So when you actually get to it, you're numb to the pain of being scared. No, it really. I want to prepare you for that because this chapter's been okay, and then it does jump. You'll be ready for that. Don't be surprised tomorrow. All right, here we go. The first one, 9 over 16x squared. Plus 7x over 12x to the third. Okay, I want to get that common denominator. So I look at, sorry?
We asked like, could you factor the bottom?
Okay, yeah, you could, if you're saying factor this, you could do like 4 times 4 times x times x. Or 2 times 2 times 2 times x. But when you have just numbers and variables being multiplied together, no adding or subtracting down here or down here, you're pretty much factored. But what's the GCF of 16? Wow.
48.
What's the LCM of 16 and 12? 48. That's the numerical part. And then what's the LCD of x squared and x cubed? X cubed. Again, you're going to do, if you wanted to verify that, can x squared fit into x cubed? Yes. Can x cubed fit into x cubed? Yes. Or can you divide? Yep. So that's what you want. 48x cubed. What did I multiply the first fraction to get that denominator?
3.
Yes, 3x over 3x. So the number part was 3, 48. X times x squared, x cubed, so it's 3x. What do I get in the numerator? 27x. That's my new fraction I'm dealing with. All right, the second fraction. What do I multiply by? 4 over 4. What's 4 times 7x? And then 12x cubed times 4 is 48x cubed. So that worked out. Now I can add numerators, 27x plus 28x. 55x over 48x cubed. All right, get your excluded values. How many could you have?
3.
Hold on, how many? No. Always get your excluded values first.
3.
3 of them, they're all 0. So x does not equal 0 right there. And then, okay, no. Can I tell you something here? I'm going to tell you guys because I trust you guys not to let this spill out of the room here. Ready? So what did you just say? What did you call that right there?
0.
Because it reminds me of Benton in his class. When I was in 7th grade, I used to say this, I don't even remember because I've corrected not corrected myself, I've switched the way I say it. They used to say that I said zero. I don't even know. But they used to, every time they saw a 0, they would say 0. I'm like, I don't say it that way, and they would get on my case about that. So I was so self-conscious. Every time I saw a 0, I would say 0. I'd make it very 0. So I hear you guys say 0, and I'm like, that's how I used to say it, but I'm not going to make fun of you about it. That's okay. That's all right. Did Benton tell you something about this? Because if he did, okay, that's fine. Yeah, so I remember changing the way I say that just because that class gave me all the time.
I say letters weirdly.
I can cancel now the X and the...
I have both is ours.
I like both. I like
Yeah, I don't say it like that. Okay, anyway, that's your
say
simplified
both.
version.
Say it.
No, 0 now. I just say 0.
No, say both.
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 Both. Both.
I have both is ours.
It's a TH.
Just say B-O-T-H.
B-O-T-H.
Like, but together,
How do you
not.
pronounce the word spelled B-O-T-H?
How do you pronounce the word spelled B-O-T-H?
Andrew, do you remember 0 to 0?
Both. Both.
You
don't
tried really
say it
hard
that
on
way.
that.
No, I emphasize the TH on any of my TH sounds.
Do you
Just say it
Saul
right
or
now.
Saul?
Both.
Patrick, fast.
Both.
He said both.
I said... All right, next one. 7 over f plus 4 minus...
Wait, could we simplify? Can we make it x squared? And then x?
Yeah, I think I did that.
5 and then...
Whoa, where'd it go?
Great, welcome back. How long have you been here?
Miss McClellan.
All right, guys. I need a common denominator, and it's very tempting to say f plus 7, f minus 7. Okay, here it is. This is a binomial, and that's a binomial. So the common denominator is f plus 4 times f minus 3. It's the whole thing. Sorry, I'm going to split this up. Wow. Actually, that's very rational. Because these are binomials. So they have to stay together.
Why don't you just multiply it by 3?
It could work.
We could get
But that's okay. Zaro. That's like Portuguese 0. It's not even Spanish. 0.
Nobody really cares how you say it.
I know, right? I feel so good about myself. Okay, here we go.
Say whatever you want. Someone's-
What do I multiply the first fraction by? F minus 3 over F minus 3. Those are binomials. If you want to put binomials in parentheses or trinomials into parentheses, you could do that. That's allowed because that's proper. And so you're left with 7F minus 21 up there. 7F minus 21. Then I have to multiply the second fraction by
Over.
F plus 4 over F plus 4. And then you are left with 2F plus 8. 2F plus 8. You don't have to, but if you don't put it, like on this one, for example, if I didn't put this in parentheses, I would technically put F minus 3F minus 12, and then combine like terms, but that's not what it is.
Like this every time. Yeah.
All right, be careful on this. You could do stay, change, opposite if you wanted to, which I would suggest.
Is there another one?
Yeah, you just,
You can just choose that.
you could do 7F minus 2F, which is 5F, and then negative 21 minus 8, which is still negative 21 plus negative 8, negative 29. The only problem with that is that if you did not, like, let's say you had, watch, I'm giving you something because I want to help you. If you had like this, you would put 7F minus 2F, 5F, and then you do negative 21x, there's no like term, negative 21x, but then people would just do plus 8. It's actually minus 8 because it's 0 minus 8, which people don't remember, so stay, change, opposite is better.
Where did the X come from?
I threw it in there, sorry. I said, for example, if you had that. So it's not there. Okay, but I still do have this. What are your excluded values?
4 negative, 4 negative 4
Positive 3.
And can you cancel anything out? No, nothing factors out from the numerator, therefore nothing cancels out. Do number 10 on your own.
Oh wait, I can change.
Don't get it wrong. And then number 11, I want to see how you guys do, and if you have time, I'll go over it. But I'm going to let you guys have a chance. Bye-bye, Swivel.